So, hi everybody and welcome back to C++ tutorial series for absolute beginners. This is video 267, and in this video we continue with our abstract class. We finished the first part here, we talked a little bit about it, and now we go here to the second part. Please stop here the video and read this one, or just open up the page and read this part on your own. But we dive into these examples here, this code section. All right. I get started. So first of all, what we are creating here, you can see it's a struct and it's called abstract. In this code snippet here, they try to introduce these two words, abstract and concrete, but in a strange way with the name, because abstract and concrete has a very special meaning in C++. Abstract means, which we already learned, you are creating an abstract class. And concrete is the opposite, which is not abstract, which means you have a class which can create an object. For example, here on top, the base, you can see there is no pure virtual specifier, this one here. So this one is a concrete class. Concrete means you can create an object, you can create a variable and can use it. On the other hand, here you can see we find here this pure specifier, and then we already know, okay, you can't instantiate here an object, which means this one is abstract. And here in this example, they are called the name of the struct abstract and concrete just as an example, but what they really mean is this one should be an abstract struct, and we can check this. How we can check this? Very easy. You just need to identify this one. Yes, we found this equals 0 with virtual function call, so we instantly know indeed this is abstract. Okay, then we have here again a struct. It is concrete, and concrete, like I said, it is not allowed to find this one here. Do we find it here? No, but we still find the function f, but the f, you can see now, it is overriding this function here, and it is providing a definition, and that is the normal use case of pure virtual functions. So you are declaring in one higher hierarchy any pure virtual function, like you can see it here, and then you want that the derived class or struct in this case should implement this, and they are doing it here. They are overriding this one, and this here is later the implementation. So here you write your code in it in the body. So that's the normal use case of pure virtual function. And then what we see here is they are just defining a new virtual function. And again, don't forget, when you see this virtual as a starter, just create a virtual destructor as well, just so in general. And then we are going here to the next one, which is, again, here we have a struct. It's again inheriting. This time it's inheriting from concrete. And here we will see what kind of class this is, and you immediately can see here this equals 0, and then you know, okay, this class or this struct is also abstract, so no worry about this one. And it's easy to identify, but here, very important perhaps, this sequence, we have here G override. When you see override, you know there is already an existing virtual function in the parent class. You can see here this one has this G here, which we have defined. And interesting is also you are converting this to a pure one. That's also interesting, because like I said before, the normal way is you create first a pure, and then you want most time that the derived class are implementing this one. But here they showed a special case where they defined a virtual function and then they make it pure. This is not the normal case, let's say it this way, but it is possible. And then we go here to the main, and then it's you can see what they are trying to do in this comment. They are trying to create an object. They try to instantiate this struct here, and we can't do it because we have identified a pure virtual function in it, which means it's abstract, which is not allowed, and that's why we get here an error. So far easy. Then concrete B, like I said before, destruct concrete. There should be not this equal 0 sign, and it's not. We have F here, but we have provided it a definition, so it is not an abstract class here or struct, and we can instantiate a object, which is B here, creating a variable. All right, perfect. So far easy. And here you can see also we can do the same thing with references. We can reference from our base class. You can see abstract is here, and then we are referencing to concrete. This is allowed. And you can see here what they are doing. They are just using now the reference variable A and calling F. What happens here? This one is a virtual call. So what happens here? Let's follow it. So we start here. A is abstract. Abstract is here, but we are referencing to concrete, which is here. We know this. This is for virtualization, which means if we have here a virtual function, and indeed we have, it will check later if this is the final override, and indeed we find here another F, and this one becomes our final override, which means if I call now with A this F here, which is indeed calling this F here, but from here, then it checks first this one, starts here, this is virtual, and then I go here in this one, and then we have it. So this is virtualization call, right? It starts here and then here, and we have it here. All right, that's what we already know. And now here, this one again, and this is the same example like this one. Now we are trying to create a variable for abstract2, but we already identified it is pure virtual, so we get an error here. All right, so far so nice, and I want that you stop again the video, read this part here, because I will jump directly in these examples here. So stop the video or just open up the page again and read this, and we start now talking about these examples here, and it starts with a struct abstract. Again, they are using these words, but important is not that it is called abstract, that you find this one here, because this little equal sign makes it real abstract. This abstract struct. If you can't find something like that, and it will be not abstract, it will be concrete, we can create it. Okay, what we have here? We have here a pure virtual function, because pure, we have found this one. Very fine. And then we are defining a normal virtual function, not non-pure, but still virtual function. And they are defining here an destructor, but again, if you have a virtual, just make a virtual destructor. And in this case, they are defining a normal destructor. That's okay, but careful about what they do here, at least what they are trying to present here. I said, if you see a destructor, it is better not to call anything in the body, only more for advanced people. Why so? The answer is very simple. The destructor has one job: to clean up this object, right? So the compiler created, for example, anything, and then need to clean up. And you don't want normally that the destructor is calling while it is trying to clean up the object other functions, right? Here you can see they are trying to call in the destructor body the function G here. But here you are normally in the cleanup process. So you are trying to do something else there while you are cleaning up, and that can cause problems. In the worst case, it causes bugs, which you can't even find very easy. So that's why for starters, don't do this. Advanced people will still make this, but what they are doing is most time customize the cleanup process for special cases, and they know what they are doing. But as a starter, I would suggest don't make this one. If you really want call G, then call it not in the destructor. Call it before the destructor. Call it anywhere which makes sense to call it, right? Not here. All right, but let's go through now. And here you see it says here the G call. What is that? this one, G, is a virtual, and we are in the destructor, and then it says here it is okay, calls abstract G. This one here, abstract G, this is allowed. And now we look on F. This looks similar. Look, we have here G, F, and here I call G, here I F, and this is not allowed. And the reason for that one is very simple. Pure are not allowed. You can call normal virtual functions, but not pure virtual functions. Okay, and then something strange happens. Here, F is not allowed, but now F is allowed. You see this one here and this one here. They look very similar. The only difference is they use here the class or struct name in front, and now this is allowed. What happens here? What is here what is the thing here? And that here, what you see right now here is that thing what I showed you or tried to explain you in my last video. It is a non-virtual call. You can suppress this virtual keyword here and make it a just normal function call, F. And if you do so, if you do something like this function here, it's pure, which means it has not a definition, but you have to provide a definition outside of this struct here one. So with other words, you write outside this one, abstract F, and then a definition. Only you are not allowed to write it inside here. All right. And this one is a non-virtual call, which means then you are calling the default version, the non-virtual virtual call, like it says here. All right. We make here later an example here because I copy this one and demonstrate you this in a moment. But let's go on and see what is here still listed. And let's go here. It says here definition of a virtual function, and then you can see, here we have it. So this one here is exactly what I wanted to show you normally. I said this one here is calling this, but it is a non-virtual call, and because it's a non-virtual call, it must be provided with a definition, right? That was what I said, and look what they have here. That I mean, it is strange because when you see a pure virtual function, everybody says no, you are not allowed to define, make a definition, but you can see you can do this. And the reason for that is, that was in my last video. Let's go here again to virtual function specifier. You are trying to do a non-virtual function call, which means you are trying to suppress here this virtual, and then it's a non-virtual function call. You call, for the base function here. And here they are providing indeed a definition. What is the definition here? This part here is normally not allowed, right? But they are doing this one. All right. That was what I wanted to show you, but I will show you this later here in the code with the compiler calls again, that you can see this a little bit more in detail. And let's go on here. That was that. And then we have here a concrete class called concrete. We have to check if this really is concrete. How we can check this fast? Do you see anything with a 0 equals 0? No, then this one is indeed a concrete struct, and we're inheriting from abstract. And now here we see void f override. So override, we know there must be a virtual function anywhere. Here it is indeed a virtual function, and this is not only a virtual function, it is a pure virtual function, because we see this equal sign here, 0, and that means we have to provide this one here, this definition, not necessarily here, because we can provide it here as well. Not then this one would become also abstract if I am not providing this one here. But they are providing here one, which means I have now a definition. And interesting is what you see here, what they are calling. They are calling f from here again, calls pure virtual function. Actually, it is the saying they call a pure virtual function, but in reality they are calling the non-pure virtual function version of the pure virtual function. That sounds a little bit strange, but I hope you understand it. They are calling this one, but they are using this colon here, this one, the special call here, which means don't use virtualization, just this one here. And this one has the body here definition. Because if you would really call a pure virtual function, that would be this one, the whole, and this one, the body here, something like this one is indeed not allowed. So careful about this kind of stuff. This one is irritating many starters. And yeah, I hope you see this and understand it. If not, no worry, in future you will. And then let's go on. Let's see what we have here. Void G. Again, it's an override. If you see this override, you should automatically know, in the parent class or anywhere there exists already a virtual function for G. And when we watch, indeed, here is it. This is a normal virtual function. And we are overriding it, which means this one can use with normal virtualization, what we learned. So when I create here an object, it checks if this is the final override, and then it checks here, oh no, I have here an override, this is the final override, and then I can use that for virtualization purposes. All right, that's almost finished. There is one more thing, and here again we have a destructor. And again, when we make a destructor, don't make something like that. Don't call functions, because destructor has just a job clean up. And here what they are doing is, for demonstration purposes, they call G, and you can see it will call this one here, and then it happens, and let's see what happens here, F. So the funny part is here, F call, and it says here it's okay. Why it is okay here? I mean, look what happens. Here's a destructor. And if you read this part here, we should not call up this virtual function, pure virtual function. And what they are doing here, indeed, they are not calling a pure virtual function, because you don't have to make the mistake. This one here, it comes from a pure virtual function, which was instruct abstract. Here it was pure, but we override it, and here it's no more pure, and we can call it. That's the reason why we can call it here, which was before. You can see F here. The F call here was a problem, pure virtual. Here the F call is not a problem, because this one is no more pure. This is just has a pure means most time, not most time, pure means just it has here not a definition normally, right? And here this one is not pure, it has a definition. And when you when you call this one, it can use this body here. When you call this one here instead, this one has not body per definition, because it's pure. And here again, the other version of F, this is not a pure virtual function call. This is kicking out this one, kicking out this one. It is just calling void F, and then void F is defined here. And this why this one is allowed. All right, I hope that makes a little bit sense. And now what I do fast for demonstration purposes, I just copy this one here. This one I copy here to C++. So you can see this one here is exactly the same. I changed it a little bit. And what I did here is I created my own virtual function. Let's create it from scratch so that you can see here. I called it virtual void test. That was not in our code here. I just added it here. And now I have created a virtual function. And then what I did also is, to demonstration purposes, I want to show you I can provide for this one a body. Here, void abstract. It is here the abstract. And I provided for my test, which I just created, a definition which is not allowed if you are calling the pure virtual function, which is true. But if you are calling the non-virtual version of this one, which means you are skipping this and this, which is just void test, I can call this, and we can see this in a moment. So here I have, then we go here to the abstract function. You can see I have to override my test. Why I have to override it? Because this one is virtual and I have test and this is pure, which means you should override it if you want to use the version virtual void test pure, so the pure virtual function. And here I indeed override it, and I said call from concrete with virtual, because this is the virtualization call. All right, and then here f that was already there, and here I added to this f override here what they had my test as well. Okay, and then they had here G that was already there, and that was the code from here what we discussed right now. So you can see I just added this line here. Then I had to create it also a definition outside for the non-virtual call for this call here if I want later. And then I override this in the derived class, and then I called it here an f for test purposes. And what we are doing now is we are using the compiler, and we make here a breakpoint to debug so we can see what is doing what. So first of all, I said, okay, I have to create an object. Here again, can I create an object of abstract? Let's see if I can. Let's make it so you can see abstract. Here's my abstract. Here's my abstract, and say my abstract. And you will see we have an error, and it says here object abstract class also is not allowed. Function abstract test is a pure virtual function, and function abstract is a pure virtual function. So you can see it says we have here two pure virtual function in this one, which is this one, and that's why we are not allowed to create here an variable, which means you are not allowed to instantiate it. All right, we figured out this I can't. And then I said what you have to do normally is you can derive from this one. Yes, we indeed derived from here. And then you can create an object of the derived if this one here is not abstract. You have just to check that this one is not equal 0, and indeed we have here no equals 0, which means we have here no pure virtual functions, which means I can indeed create this variable here. So I created this variable, my concrete object here with this concrete here, and now I want to use it. And now I make a very easy use. I say my concrete object, and I call f, this one here. I will call it because I can, and interesting is this f here. It will call abstract f, we will see what this happens, and it will call also my function which I included. And let's start this program and go step by step with the debug here and see what happens, and I try to explain you this as well. So I start, first of all, it is compiling, it is working, that is a good sign. So why is this a good sign? Because here, that means I can provide definitions here. All right, so now I'm here in my debug, it stopped here, and let's use here again this step into. And the first thing when I step into from here is jumping to my f, yes, because this is my object here which I created. It's jumping here to the abstract, it's jumping here to f, which is an override. This was already resolved with the call here from virtual void f was resolved. This was that's why it's jumping here directly to this point, and from here we go also in it. So bang, so I'm here, and now I jump here in it, abstract f, and here abstract f, what happens here? It calls pure virtual function. Let's see, we jump into it, and it is jumping here on top. This comment here is irritating. It is not calling pure virtual function. It is calling the non-pure virtual function version, right? And what they mean here is with this comment is it is calling this pure virtual function, but careful, the non-pure virtual version. That's why it is jumping to abstract f, because it goes here first and says, wait a minute, this is the pure virtual function, but here we are calling actually, where was it here? We are calling the non-pure virtual function. That's why this one, I know, the compiler knows this one should have a body, and that's why it's jumping here. that's here, is it? And that's why we are here with the compiler. And let's go on a little bit. And then here's just outputting AF called abstract. A stands probably for abstract. Abstract F called. Okay. Then it goes, we are finishing with this one. Then it goes back to the function f again because this one is finished, and now they are calling my function which I created, the same thing actually. It's jumping again here in. Why it's jumping here again? Again, it is normally jumping here, but it sees this is not the pure virtual function call because that would be here on top. I'm trying to call the non-pure version. This is the void test, and void test I have provided a default version, and that's why it is jumping here. All right, we have this, and we go in, and then it prints this one out. Okay, and let's see what happens then. Then we are finished with this call. That was the call, but let's see what happens with this destructor. I have never demonstrated this one. That's why let's go on a little bit. So then here, the call is finished. So this is finished. This is finished. Now we are finished with main. We are returning to 0. But careful what happens now. Bang. It is jumping up, and it is jumping to the destructor this time. Why it is the jumping to the destructor? Normally we never see this one because we have never created till now destructors, and this one is an explicit destructor creation, which means this one will execute now this body what you have provided. And like I said, normally you should not make this because this is a cleanup process, but let's see what happens. Before we go on, the question is, wait a minute. We have here a base class. This is abstract, and then we have this concrete class. Why is the compiler jumping to this one here, concrete? Why not to the base class first? And here you have to remember, destructing of object is the reverse order of creating them. So when we, for example, created this object here, my object here, what you do is you jump here to your concrete, but the concrete says, oh, wait a minute, you have inheritance, which means this one is incomplete. I can't create this object concrete. Then the compiler is jumping to the base and says, oh, this one is complete, has no inheritance. I can create this first. After it finishes this creation, it is jumping back here to your and create this one because now it has all the information. So the construction is first base and then your class. But destruction, we are now on the destructor, and the destructor is the other way around. So what was first created becomes last. This one was first created, so this will be my last one, and this one was the last created. This one is my first one now. So the reverse order. Okay, and now you understand this. Let's go and see how the compiler is going here through. All right, it's going in, so it will destroy my derived class first. And you can see this one you should normally not do is calling G. Let's see what G is. We jump in. It is this one here, and we see this G is again a virtual override normally. So here and then jumping from here, and then let's go on. It is calling F, and then let's see, yes, again this one here, that was the other example why we can call F here, because it is this F here, which is not a pure virtual function. Careful about this one. The other F here on top we can't call anyway, because this one is indeed a pure virtual function when you call it this way, because there is not this colon here with the concrete, because if you want to call it this way, like so, then you are calling the non-virtual function. This way is calling the pure virtual function. That would cause here on top an error. All right, that's also clear. Let's jump into and go a little bit higher. So this one is here going to F override. It jumps here in the abstract F, and abstract F was what? That was what I just explained. Now we are calling the F version the non-virtual version, which means we are calling not this one, because this one has not a body, but we are calling this part here only, which has a body here, and we will jump there now. Let's see if this is true. So we go in, and you can see we are again in abstract F. Okay, then we are making output again here. All right, and then we are going to my test. This is the same thing like before, what I showed. And then it is going to my test again, this one. And then when we are finished with this one, it is finishing the destructor. And what happens now? Remember, we are not finished. This one will now jump to the base because that was the reverse order. We have finished just clean up concrete. This one is finished. This object clean up. We have concrete object cleaned up. Now the compiler will jump here to clean up this object here as well. And when I go into, you can see it jumps now to the destructor of abstract. And again, we see this only here because we have explicitly created this destructor. Normally we don't create it in other, but when you have a virtual, you should anyway create a virtual destructor here. But you don't have to provide this body here. Normally what you are doing is just set equal default for optimization purposes. And like I said, this body here, make this only if you are at once for special cleanup sequences or something else what you will do while the compiler is cleaning up. Anyway, let's continue here this example, and it goes here now to clean up this object here, and then it goes in here, it calls G, and you can see it can call it because it's not pure virtual like the other ones have here virtual. And from a constructor, you can see here this example again, you can't call F. F is not allowed because this would be now a pure virtual call. And don't mix it with this one. This one is a non-pure virtual call. This is this version here, the non-pure, and this one would be called the real pure virtual version. That's why it's not allowed, and that's why it says here undefined behavior. And here, let's go in here a little bit, and here you can see this abstract F that looks identical. It's not. This one now, it's calling exactly that what I showed you here. It is calling this version, which means it will jump here down again. And when we go into it, indeed it is jumping down, and then it's executing this one, and it's going here, and now we are finished here. And what happens now? We are going back to, yes, we are going back to this not really to this constructor here. We are going back here. That is the real place where we're going back. And then here we are finished. And yeah, but I hope you understand this one and see the steps. It's not too difficult. The only really a little bit confusing part is really this call and this call. If you understand this one, yeah, I mean now why this one is undefined behavior and why this one is allowed. That was again non-virtual call. This is just this part, and then they can call this part here. That is probably the most difficult part here to understand. And of course, you have to understand this destructor calls, when to use virtual, when not. This example is not very nice in because they don't care about virtual destructors in this example, because they are trying to just to show the concept of this pure virtual function calls. What I mean with that is, again, when you see this one, make virtual destructor here definitely, and something like that. All right, with that said, this video is also finished. And if you have any questions, like all time, write in the comment section. See you on the next video. Bye, good luck, and have fun.